given. Triangle ABC is a right triangle. Triangle ABC, right. What else? Altitude CD is drawn to hypotenuse AB. So CD is perpendicular to AB. Okay? You have to prove that BD over CD equals CD over AB. All right? And this is my triangle. Triangle ABC. Okay, A, B, C. This is my right angle. From this right angle, you have the altitude, the hypotenuse. Well, imagine that's a straight line, right? CD. And we have to prove that BD over CD is the same as CD over AB. We did it in class yesterday. So let's see, how can we start showing that? BD, CD, CD, AD. You guys notice here that we're dealing with the small triangles that are formed here, right? We have this yellow triangle, ADC or CDA, and the other triangle, this proportion here given to us, we can prove that it's true or not if we can show that the two triangles are similar. Triangle CDA and triangle BDC. Are they similar or not? Well, let's see. This angle A here and this angle B in the big triangle ABC, they're what to each other? Angle A and angle B, they should be in what relation? Knowing that this angle C here, the 90-degree angle, is given. These two angles should be what? They should add up to what? 2? We're talking about a triangle. 1. Well, all 3 of them add up to 180, but these 2 only will be in what relation? They're complementary. They add up to 90 degrees, right? Good. Moving into the yellow triangle, into triangle ADC. I know this angle here is 90 degrees because CD is perpendicular to AB. If this is angle A, what can you tell me about this angle here? Angle ACD will have what value? If you know that measure of angle A plus measure of angle B equals 90 degrees. This is in triangle what? In triangle ABC. Okay, I know that. That's a fact. In triangle ACD, what can you tell me about the measure of angle A, excuse me, plus the measure of angle ACD? Should be what? Knowing that this angle CDA is a 90-degree angle. Angle A plus angle ACD should equal what? Anthony. This angle and that angle right here, this one. If you add them up, they should give you what? Paula. 90 degrees, absolutely. Guys, in a triangle, in any triangle, the sum of the three angles is 180. Well, this one is 90. These two better add up to 90 degrees because if not, you don't have a triangle. You have something else. Or you may be on a different planet. Planet Earth, in a right triangle, the acute angles add up to 90 degrees. So these two are 90 degrees. But looking at this statement, first statement and second statement here, I've got A plus an angle B in that case, and A plus another angle Both make 90 degrees. What can you tell me about this angle and this one? They're in what relation? They're what to each other? They're congruent. Alright? So from these two statements, I can tell you that the measure of angle B is the same with the measure of angle ACD. Well, knowing that, what can you tell me about triangle ACD and triangle, let me see which way, ACD, okay, triangle CBD. CBD. They will be in what relation? I got two angles, 90, 90, and I have this angle and this angle congruent. By what case of similarity? By the case, angle case, the two triangles are similar. Okay? And I can show, you know, pretty much using the same approach that this angle here is the same with, you know, the angle BCD is congruent to angle A from the big triangle, angle CAD if you want, by the same approach that, you know, angle A plus this small angle here, or angle A, let's have angle A plus angle B is 90 degrees. Well then, in this green triangle, which is also a right triangle, angle B plus that small angle BCD also have to add up to 90 degrees, which makes this angle BCD congruent to your angle CAD, your angle A from triangle ABC. Two triangles similar. Let's write the similarity statements, which basically say that the corresponding sides are having the same ratio to each other, right? First side from triangle ACD, side AC. If triangle ACD is similar to triangle CBD, then AC, which opposes a 90-degree angle, over CB, which in the second triangle also opposes a 90-degree angle, will be the same as the next side, CD. CD opposes angle A over BD, right, which also opposes an angle that's congruent to angle A in the green triangle. So CD over BD will be the same as the third side in the first triangle, AD over AD over CD. Are we done or not? We have to prove what? That BD over CD is the same as CD over AD. Well, let's look at my two ratios here. My last two ratios. Let's take it separately. What is that? Well, is CD over BD equals AD over CD. We have to prove what? That BD over CD is CD over AD. But from this statement, knowing that if A over B equals C over D, then B over A equals D over C, I can write it that way, right? I can write the same equality statement for their reciprocal. I can say that, you know, also BD over CD is the same with CD over AD, and we are done. Because we were supposed to prove that, right? And we did. BD over CD equals CD over AD. And that's how you solve this problem.